Hi, this is Mrs. Cribb again. We are going to cover in this video Chapter 3D, Orderly Problem Solving. And this is just basically to help you practice thinking through how to be logical in problem solving. I give you some general guideline steps. Read the statement of the problem. I usually circle important information. Determine the method to use to solve the problem. Choose the specific tools to use, including formulas or charts, and a lot of times you're going to have to use charts. Set the problem up, no numbers in the formulas. Estimate and calculate the answer. So basically you want to find out if your answer makes sense. Check your answer to make sure you actually answered the question, and check for units and significant figures. So this is the process that you're going to go through, and we're going to step through it every single time. So let's do this first problem together. An experiment requires 45.6 grams of isopropyl alcohol as a reagent. Instead of measuring the mass of a liquid on a balance, you decide to determine the mass by using an equivalent volume in a graduated cylinder. That just means you're not going to measure the mass, but you're going to put it in a graduated cylinder, which is one of those tools that looks like this with the markings on the side, and you're going to pour it in there, and you're going to figure out what volume you need so that the volume would equal that grams. The density of isopropyl alcohol is this. And the other key word here is that's density. What volume? Here's the question. What volume of alcohol is required for the experiment? And so I noticed the word density, so I'm going to pull up the density formula, and the density formula is in your notes. There it is. Mass over volume. Okay? So density equals mass over volume. And I'm going to use that to solve. Now, there is a cheat that you can do for density equals mass over volume. Okay? And density, I think it goes like that. Yeah, there it is. Density equals mass divided by volume. Or if I wanted, imagine putting a finger on top of volume. If I wanted to know the volume, so cover up volume of what's left, mass divided by density. Or if I wanted to know the mass, what's left, density times volume. Okay? So in this case, what is the question? The question is volume. So I'm really going to solve for the denominator in this case. So I'm solving for volume. So what do I have left? Mass divided by density. So volume is equal to the mass divided by the density. And I could solve it two ways. So let's put in what I know. The mass that I need is this, 45.6 grams. So if I do it over here, I'd say 45.6 grams divided by the volume is equal to the density, which is 0.785 grams divided by milliliters. So you see we kind of had, we have fractions on both sides. And now I'm going to solve for V. There's nothing wrong with solving this way. I just noticed that students make more mistakes when the variable they're trying to solve for is in the denominator. So you can, when you have a variable in the denominator, and we are going to have these, you cross multiply. So cross. So 0, my pen is acting up, 0.785 grams. Let me erase that little mark right there. Okay. Times V equals, there's the other side, 1 milliliter. Remember, if there's no 1 there, you just write milliliters, but you can write a 1 there, times 45.6 grams. And now I got to isolate my volume, my V, isolate V. There it is. Sorry about this. Okay, so I got to divide by 0.785. So V is going to be equal, because I divide both sides by 0.785 grams. Divide this side by 0.785 grams. Okay, so that V is equal to whatever that's over here. And now we have to remember canceling units, grams on the numerator, grams in the denominator, so they go away. The only unit that's left is milliliters. I didn't cancel that. And then I would do my math to figure this out. Okay, that number when I do the math, is 58.089. That's a raw number. And the unit is milliliters, so I have to look at significant figures. This is a multiplying. We're multiplying and dividing. So we use the least number of sig figs. So this number here has 3 significant digits, and this number has 3 significant digits. So my answer needs 3 significant digits. So 1, 2, it's got to end right there. So I look at the next number, that's an 8. That tells me the 1 has to round up in order to get it. So it becomes 58.1 milliliters. So if I measured 58.1 milliliters in my graduated cylinder over here, it would weigh, or it would mass out to be 45.6 grams. Now, what about this top one? I just used the cheat here. Volume is equal to, and so I use this little triangle cheat. The mass now here is 45.6 grams. Density is 0.785 grams over milliliters. Okay, grams cancels again, so I'm going to kind of find a, oh, sorry, my cursor is not, no, cancel that. I wanted to get big. There we go. My cursor is giving me some fits right now. So grams cancel, and now I only have milliliters left. And this is a complex fraction, but right now you just need to know milliliters are left. So when I do this, notice it's the exact same numbers as right here, and it becomes exact same answer we did before, 58.1 milliliters. You still have to count the 3 sig figs here and the 3 sig figs here and round the 4 sig figs to 3 sig figs. Okay, that's the first problem. Let's try the second one. A lead fishing sinker, you know, one of those little gray things that on the end of a line, has a mass of 51.0 grams. The density of lead is 11.34 grams per centimeter cubed. I'm writing it over here because it's written right there. I'm just putting the unit right next to the number. Now notice a lead sinker is a solid, so I use the centimeter cubed. Up here we had a liquid that we're putting in a cylinder, so we used milliliters. Again, what is the volume of the sinker? How much space does that sinker take up? Well, we have to write the formula again, okay? So we already did the cheat for volume up here. There it is, volume. So I'm going to rewrite it. Volume equals mass over density. Don't know what's going on with my pen. There it goes. So mass is 51.0 grams divided by 11.34 grams per centimeter cubed. Okay, now let's cancel out units. Grams and grams cancel, so centimeters cubed is what's left, so that's going to be my unit. So whatever it is, it's going to be centimeters cubed. And then we do the math by putting in the number 51.0 divided by 11.34 to get 4.497. Okay, 4.4973. I'm putting more than I need. Then because we're dividing, we have to look for the least precise, or the least number of sig figs rather, least sig figs, because we're dividing and multiplying. We look for least sig figs. So there are 3 significant figures here. There's the decimal place. You come in from the Pacific, 3 sig figs. There are 4 significant figures here. The least number is 3, so it has to be 3. So 1, 2, 3. It has to end in the hundreds place. Now this is where you have to think for a moment. I have to end here, so I look at the next number, and that's a 7. That 7 is going to cause the 9 to round up to a 10. But I can't put the number 10 right there. I have to scoot the 1 over to here. I can only put the 0 there. Well, that 1 has to be added to the 4, so it's 4.50 centimeters cubed. That's the final answer. So remember, if you round a 9 up to a 10, you leave the 0 where the 9 is, and you take the 1 and add it to the next spot. Okay, that's how you do problem solving. You think carefully about what you have, you circle what you need, you use the formula that you need. and then you make sure that you actually answered the question. So in both cases, I asked for what volume it is. And volume is in either centimeters cubed, in this case, down here at the bottom, or volume is in milliliters. That was in the first question. So I did answer the question. Okay, that's the end of this part, and I will see you soon.